Hey, welcome to this lesson. It's on operations on polynomials. The specific operation we're going to be looking at is combining like terms today. We're going to talk about what a term is, what makes terms like terms, and why you can combine them, and then go through some examples of how you can combine them. So let's take a look at our first example here, 5 plus 3. 5 plus 3 seems really simple. It's something that you've been doing since probably first grade, maybe even kindergarten, where we've been adding the numbers 5 and 3 together. But why are you allowed to actually add 5 and 3 together? What allows us to put these together, but then when we change it, all of a sudden, including variables, we can't put it together? We want to talk about that. So let's start off and let's just add this. 5 plus 3. 5 plus 3 is 8. If you have 5 items here and you're adding 3 more items to it, we now have 8 items all together. We just put those two together. Now, what happens if we change this slightly and add in an x? Now, all of a sudden, we have 5 x's, and we have 3 constants, and when I put these two together, we notice that they're no longer the same thing. We're not talking about these little dashes anymore. These numbers are units. Rather, now we're talking about 5 x's and 3 units. They are not like terms and cannot be put together. All right, and that's what we want you to see. We want you to see that they are not the same, okay? And to explain that a little bit, I want to show you why. Because some people would think, oh, 5x plus 3, that's 8x. But you'd be wrong. This is why. All right? If I have 5x plus 3, as we see up top here, we cannot put those together. Down below would actually be what we're looking for, what some of you thought maybe we could do, where we'd have x times 5 plus 3, which is, and if we take that out, 5 plus 3 becomes 8, and 8 times x is 8x. So this expression is indeed equal to 8x. But what is this expression? If I were to distribute that x, I actually get myself an expression that is 5x plus 3x, concluding that 5x plus 3x is equal to 8x. That's because 5x and 3x are like terms, whereas 5x and 3 earlier are not like terms. What makes 5x and 3x the same term? It's because they're both being multiplied by the same variable. Anytime you have two terms that have a common factor, it's going to be making them like terms, and we can put those pieces together. The common factor, the part that both are being multiplied by in this case, is x. And that's where the distributive property can actually show us why we're allowed to combine these terms to begin with. Since they're both being multiplied by x, that means that the x could be pulled out front, something we'll come to know in Chapter 8 as the greatest common factor. Since it's pulled out front, I can then follow my order of operations, allowing me to add my coefficients together to get 8. And then I can go back to multiplying the x with the 8, giving me 8x. That's why we're actually allowed to combine like terms. And you'll get more into that in Chapter 8. So what do you really need to know right now in order to do this skill? Well, you need to be able to identify like terms. And to do that, you need to notice that every term, every piece of the equation separated by addition or subtraction, has the exact same variables and exponents on those variables. All right? Or they're all being multiplied by the exact same item, as we'll see in the next one here. Take a look at these terms. These are all like terms. So as we look, we've got 5x, 4x, 3x, negative 15x, 0.25x. The coefficient, the number in front of my variable, is different on all of these, but my variable is the exact same in all of them, making them all like terms. The next one, we have x squared, 5x squared, 4x squared, negative 2.8x squared, 1,981x squared. All these are being multiplied by x. They are x squared. They are not the same as x, because x squared means x times x, all right, whereas x is just one of them. Two different terms, all right, they are not the same. They must have the exact same variables. One only has 1x, the other one has 2x. It's got to be careful. Look at our y, 6y, 3y, negative 8y, half y, all y terms. All right, they're all consistent. And look at our last one, x squared y. All right, so we have 14x squared y, negative 2x squared y, 11yx squared. I'm going to point this one out. These are still like terms. Notice this is x, x, y, and this is y, x, x. They have the exact same combination of variables. They just put them in the wrong order. Variables should be listed alphabetically, All right. However, they put it in the wrong one. I wanted to show that to you to remind you these are still like terms because you're looking, are they all being multiplied by the exact same variables? All right. And in this case, they are. And the order of multiplication doesn't matter. It's commutative. However, we do like to write them in alphabetical order just to be consistent. All right, so that's combining like terms with variables. I want to show you where we're actually going to be heading with combining like terms in the future. All right, and that is when we get to square roots. You can actually see that these are also like terms. Notice 5 square root 2, 7 square root 2, negative 12 square root 2, 108 square root 2. They all are being multiplied by square root of 2. It's as if square root of 2 represented x. If I were to put x in each one of these spots, it would be the exact same thing. All right, so all the square roots of 2 make these the same term. And we can add them the same way we would combine like terms. 5 square root of 2 plus 7 square root of 2 is 12 square root 2, where you add the coefficients, 5 and 7, and keep what's common in between them. All right, the factor there of square root 2. So that's what we're looking at, and this is why. Again, the distributive property can show us why we're allowed to do that. Our order of operations would always allow us to do what's in the parentheses first, then multiply by what's outside, or you could distribute first and then simplify. We get the same thing either way. That's the power of combining like terms. It allows us to simplify expressions that we might not be able to simplify in any other way. Let's take a look at how we're going to use this with some examples in Study Island. All right, taking a look here, as I look at this first example with addition, looking right here, all right, it shows that I've got one group, 3x squared plus 4x minus 7, plus a second group, all right, 5x squared minus 2x plus 4. But notice we are adding in this. We are adding right here, and so in order to combine these like terms, I need to get rid of my parentheses, and since there's nothing in front of the first parentheses, it's not going to change anything when you distribute nothing. So we could just drop these parentheses altogether on this first expression. Likewise, addition, this little positive 1, as it's shown out front there. You don't see the 1, but there's always a 1 if you don't see it there. It's a positive 1, and when you distribute that positive 1, it's also not going to change the value of what's inside of parentheses, allowing us to just drop them. So if I were to just drop the parentheses, I get this expression right here. And now I can combine my like terms. And we can annotate the text in order to help us to identify which ones go together. I like to put a box or a square around my x squareds. I'm going to scan through. I'm going to find another one there. All right, notice I included the plus with it, so it's a positive 5. All right, so that when I combine 3x squared and 5x squared together, I'm using them both as positive, giving me a positive 8x squared down below. I'm going to use a circle for my x's after that. All right, notice I included the plus 4. The positive is included there, so I know it's a positive. And over here, it's a negative 2x. Positive 4x and negative 2x, when I combine those two together, all right, I get myself a positive 2x. Notice positive 2x, they just wrote plus 2x. And then my last one you can use, I'm just going to use a little squiggle line underneath, but I'm underlining the symbol as well. Negative 7 combined with positive 4, that's what we see here. We're combining those two. And when I combine negative 7 and positive 4, I get a negative 3. Notice we didn't write plus negative 3, we just wrote negative 3. That negative doubles is both the negative symbol and its minus there, giving us 8x squared plus 2x minus 3. Let's take a look at a subtraction example when I have some groups down below here. All right, taking a look at the subtraction example, all right, we can see now that I am subtracting the second group. That means that when I go to distribute, there's nothing in front, which means I can just drop those parentheses. However, here there's a negative in front. That's a negative 1. All right? And whenever you multiply by a negative, it makes everything the opposite. And so when I distribute here, all of these signs inside here, 2x squared will become negative 2x squared. Minus 2x becomes plus 2x, and plus 4 becomes minus 4. And you can see those changes marked in red here to identify the fact that it made them all the opposite. Please be careful with that. You must get rid of your parentheses first by distributing if there's anything out front, then combine your like terms. So once again, I'm going to box out my x squareds. 6x and negative 2x gives me a positive 4x squared. Circle my x's. Positive 4x, positive 2x gives me a positive 6x. And then I'm going to squiggle line my negative 7 and negative 4. Negative 7, negative 4 gives me a negative 11. giving me that final result down below. So do be careful when you have a negative in front. You must distribute that first before you combine like terms. If you have more questions about it, come see me in class. Good luck.